Alrighty guys, so groundwater diagram. You can, again, copy as I move along. You can photograph at the end or look at the video after it's posted. The first thing you want to do in establishing a groundwater diagram, there's 3 major parts that you just simply have to know. And you can start drawing that. This dotted line here, and the dotted line is going to separate our unsaturated zone and saturated zone. What is that line called that divides this? Water table, yes. So we're going to just simply label this water table. And then I know everything below the water table is where the water has filled up, it's full of water, it is the saturation zone. So below here is called the saturation zone. And then above there may be water present, but it's not full. So what do we call it? Unsaturated. The unsaturated zone. And y'all know the nerds, they have a nickname for unsaturated zone. It would be easy if they left it at that. Sometimes they call it and you may have caught this from some of your investigation, it's called the zone of unsaturated. That would make sense, but they actually call it the zone of aeration because there's some aerating going on in there. Zone of aeration. So we could have a nickname there. After you've established your main zones, again, these are the 3 major components. Let's add some land in here so it looks like a real life place. All right, and that means we want to go, I'm going to have some land.
Whoa, that's so realistic.
Coming down here. And then what's going to really blow your mind is when this gets to become, it could be a lake, stream, river. All of those are known as surface water. Okay. So we've got that going for us. And let's come up here to the top of the land, and nothing is complete without a little tree. Little Bob Ross, happy little tree.
Does it have to be a tree, or could it be like? Could it be? Yeah, like could it be any?
Well, there's no mistakes,
could
right?
It be the
Make it a bird.
forest?
It's got to be a living plant.
Okay.
Okay, so if you have a pretty flower, that's good. And what happens when plants go through all their photosynthetic processes and living and all the things that they do, they basically produce like plant sweat. And when they release some of their extra fluids, that plant sweat is called, what's the big fancy word? Transpiration. So we can draw this arrow up showing transpiration happening here.
That stuff is evaporates.
And that's important as part of the hydraulic cycle to show how the water is constantly cycling as groundwater and through the environment. So transportation occurs, and that is potentially going to make its way into the atmosphere, and as more and more of that vapor condenses, and what's going to happen in the cloud eventually after condensation? We're going to have some precipitation. With these really cool, awesome raindrops.
Man, those are some weird raindrops. They're like squiggly.
And then some raindrops hit the ground, and whoo, and they come down here just like the little, oh my gosh, our geniuses, yes. So, let's make everything labeled appropriately. So this stuff falling, we said, was precipitation. So you guys are moving faster than I can draw. And then we've got some runoff happening. Fabulous. And then we also want to make note that occasionally on like a nice sunny day, not all of this runoff is going to make its way into the water. Some of the runoff comes into the ground, some of it does what? evaporates.
Evaporation. Condensation. Precipitation.
Very good. Okay, so we've got all that going on. Some of these little raindrops, I haven't drawn this yet, some actually absorb into the ground.
Infiltration.
And when they're absorbing, that process is called infiltration. And what do we call the water once it's in the ground?
Groundwater.
Yes, lovely. Okay, so we'll call this groundwater.
What about rain?
And then I, in my diagrams, most of the time say groundwater, and we call it that after infiltration. Because infiltration really is a process, it's not a thing. So in parentheses seems to make sense for my brain. All right? Then we need to go ahead and put in our well up there. So let's get, trying to do another pretty picture. Well, actually I'm gonna stick with black so it shows up on the video. All right. So we've got our cute little well here.
That's a great looking well.
And then wells need to go how far into the ground?
Down to the saturation zone.
Right. If we did a well to here,
It's not gonna get no water.
ain't gonna get none water, right? I mean, you might get some, but not gonna get none water. So we need to take it past the water table, well into the saturation zone.
Well,
Can you draw the area?
Hmm? For
ha
what?
ha ha.
Look at the
Yep, we're gonna get there. Good call, good call. It's gotta go well into the water table. Let it be known, this water table can move.
Oh my God.
If we experience a long-term or period of drought, what do you think would happen to the water? The water table could go down. So well digging actually is a very specific science in how far down you need to dig the well. They would need research and history showing maybe about where the water table normally stays, what's the lowest it's been, so forth and so on, to make sure that well is dug to the appropriate depth. And when you dig it, I see some of your motions, you're already recognizing this isn't quite accurate. What happens to the water table even with digging?
It goes boing.
Yes, it gets depressed.
It gets the cone of depression.
So we have to have our cone of depression, which is literally the water table getting bent down. So your original water table was here, and it's now down here as the well pumps water out. And I should label that right, cone of depression.
So can you put this on a picture of this on Google Classroom?
When I'm done, I still have more accessories to
I know.
add.
We have
Okay, this is the well, okay? Next, we want to start identifying like layers that are permeable and impermeable. What do those words mean?
So if it's permeable, water can get through it, and then if it's impermeable, water can't really get through it.
Easy. Yeah. Permeable, you can get through it. Impermeable, you can't. So typically your permeable layers are gonna be up here because water is able to get through. It could be different types of soil. It could be sandy soil. It could be soil with rocks and things in it. Just like we've done our demo when we had pebbles, the water will permeate and get through there. It permeates through some types of soil better than others, right? But for the most part, this is considered a permeable layer. So I actually wrote sideways, and I wrote permeable layer for this section. And then typically down here is where you're gonna have an impermeable or less permeable layer. And what I may specify is, let's say this area along here, we're going to call this a layer of solid rock. It truly is impermeable. That solid rock we've known from our soil lab could be also called what?
Bedrock.
The bedrock. Mhm. And again, you can have lots of different types of bedrock. You could have, what's that?
You said Minecraft.
You could have slabs of different rock. Let's say, because it makes it for an interesting diagram, let's say this bedrock has some limestone in it, okay? Okay, and the bedrock, remember, changes depending on where you are in Virginia, too, from the coastal plains and so forth. So you could have lots of different types of bedrock. Now, within the bedrock, we can have a couple other vocabulary terms come up, one of which, let me make sure I'm trying the right place. If we have maybe an open area that's filled with water, what might we get to call this? This is one of the newer terms.
Confined aquifer.
This one we could call a confined aquifer. Aquifer is really just a body of water underground. So this whole area here, this unsaturated zone here, this can be our unconfined aquifer. Let's add that label in. This whole area here, it's a body of underground water, and it's not confined, it's not held in by any impermeable boundaries or substance. So we can even call this unconfined. Aquifer. And then down here, this is still underground water, but do you see the difference? There is this bedrock, this impermeable layer all the way around it. So we call that confined. It's held in there. Confined aquifer.
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 Aquafet.
Like boots with the fur. Aquifer.
That's aquafet.
Oh, look, thank you, thank you. It's not aquafel. It's aquifer. Yes, ma'am.
So, unconfined aquifer, what did that mean? A saturated zone, because that's where the water is.
It could be, yes, could be there too. Let's change it.
Yeah, because if there's no water in the
Well,
unsaturated.
there could be water there.
Oh, yeah.
Yeah.
But it's just not as full.
Cool. So we've got unconfined and confined. Then we can have, occasionally, this confined aquifer, it's closed in, so there's some pressure building up. Occasionally, if that pressure is released, it could naturally find its way up out of the ground. This wasn't really on your list, but you would have seen it in some of the readings. When that pressure builds up and the pressure is released naturally, what comes up?
Geyser?
Well, geyser would be if there were also some heated water from like being near the magma.
Lava.
But it's the same concept. If we don't have heated water or steaming water or magma, but we still have the pressure and the water release,
Wait, what's it called?
it was from a web quest.
WebQuest.
Thank you. An artisan well, artesian well. Yes.
I did not
I was
know
just
that.
Artesian well, artesian spring. And this is totally above and beyond extra, but let's go there.
Do we need to put it
How
if we
did
don't
you
have
know that,
space?
I was gonna
Miss
say
Smith, if we don't have
How do you know
space,
that?
do,
Your call.
okay.
Bet you can make space. Bet you can make space. Artesian well, awesome, so that comes
Well.
off there.
Um,
Then let's also talk about where might a cave be. We said we had to include a cave.
Under the ground.
Some of us, I know we're doing these really cool, like the Crude's family caves up here on top, which could be the cave, could be the case, but I think of caves being more
Underground.
underground,
Under
okay?
water.
So let's have a couple of caves here. Where?
There.
You want a cave up here?
Yes,
No,
space
no,
right there.
no, it has to be.
Follow
Space right there.
Well, here's the thing,
It doesn't have
caves
to be
could
like-
be
Yeah.
in the unsaturated zone or saturated zone. Some are in the saturated zone, they're just filled with water. And like this confined aquifer, that could potentially be a cave.
Cave if it drains out.
Right. And this up here, let's say there is a cave up here.
Yeah.
Draw me some stalactites.
But then you
Yeah.
could have the stalactites.
Like
and
stalactites.
Stalactites.
Can't those break?
What if I
Stalactites.
might?
We
Looks
have-
like a mouth.
Here's our cave. It could be that the water table at some point was higher
Oh, yeah.
and provided moisture, and it's become lower. We know the ground can do crazy things because it's had like millions of years to do that.
Yeah.
So this very well could be a cave in this area. And if there is a cave here, it potentially could make the area above it weaker, right?
Yeah.
Because this is empty space now. So over time, what may happen to that cave?
Sinkhole.
The cave could collapse and you may get
Why do you say sinkhole?
Sinkhole.
Sinkhole, yeah, that was, yeah. That's what I was gonna say for the artisan.
we may have a sinkhole there. And let me check, we may have hit,
Rock bottom.
Oh,
nice.
No, you did. You didn't say it.
I think we have gotten all of our pieces. Again, your diagram could look different, but if you're understanding the concepts, you still could have a very accurate diagram. Do you want me to add one more extra piece?
Yes.
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 Okay, let's stick down here with this solid bedrock. I'm gonna draw it right here, okay? You don't have to do this, but it takes it to the next level. So this solid bedrock, sometimes it may do something like this. Let's have it veer off. And then let's say there's even another solid rock here.
Wait, what? Oh,
Right. More
bedrock
solid rock.
or bedrock.
Okay.
Wait, can there be a confined aquifer there?
More solid rock here, and this is all bedrock here. When you have these layers of almost impermeable or even impermeable substances, they can be called impermeable layers or bedrock layers. The scientists really like that aquifer term, so they built on that, and sometimes they call them aquatards to be, and then they also call them aquicludes. Aquatards are layers that are mostly impermeable, so not a lot of water is really getting through there. So be mindful here, I called this whole layer impermeable. That could be tricky because it's not all impermeable. Some parts could be mostly impermeable. You see the small difference?
Yeah.
Okay, so these layers here that are mostly impermeable or would be mostly impermeable aquatards, and then if they are really impermeable, like you're just not really getting through this, aquiclude. Think of the word exclude, you totally leave people out. So aquicludes could be given to this layer that doesn't let anything through. So aquiclude,
P
I
at
think
the
you
end.
said clue.
clude, or aquatard.
Nice word.
And I'm just gonna say mostly impermeable, and then impermeable. All right, that's a lot of information. Oh, and question.
In bedrock, couldn't there be like cracks in the impermeable surface that allows water through?
Yes,
So
and that can change over time. There might not be, maybe there used to not be a crack here, but a weak spot in this area allowed for that, the pressure in this aquifer to
Makes the artist well.
come through. And then once it got through the mostly impermeable layer, it was easily able to pressurize and release pressure moving upward. Okay, excellent question.
So we don't need a new aquatard and aquiclude? We don't for Tuesday?
You don't have to add these, I'm just taking you to the next level. And they come up, you may, or likely, if you did the reading associated with all this, you saw these words and may have gotten confused because you saw aquifer, aquitard, aquiclude, confined aquifer, unconfined. That may have been confusing, so to see how they're different is helpful. These two, no, I will not ask you about these on the
But
quiz.
confined and unconfined.
Absolutely confined and unconfined, yeah. Mhm. Nice.
Is it aquitude like TDE?
Aquiclude, like exclude, aquiclude. I think we may be good on our
Wanna
video.
stop the video?
Yeah, I'm
Okay.
totally uncomfortable right now.